I hope that's all working for everyone. Good evening, good afternoon, good morning, good whatever it happens to be. Welcome back to day 2 of the WASSP presentations. Today we have 3 presentations. I'm going to start first, then we're going to have some time from Justin, and then we're going to finish off with some time from Andrew. So to begin with, I'm going to talk about sports fishing and WASSP for sports fishing. Funnily enough, in sports fishing as in commercial fishing, there's a lot of crossover, but it's there's some different angles and some different ways that we obviously look at things in a sports fishing type environment. And I am sure that there's a few people on here today, well, hopefully there's a few people on here today that have spent a lot more hours sports fishing than I have recently. I must admit, I got spoiled in New Zealand, and sports fishing in the UK just doesn't quite cut it in the same way. So then we're going to move on to Justin's going to come back and he's going to talk about super yachts and cruise ship navigation and using WASSP for navigation of sport super yachts and cruise ships, and the various different options and how we can make that work very, very well, and some of the success stories that we've had recently. Quite a strong and growing market. And then Andrew's going to come and talk through some technical training on the hydrographic survey type applications. So still using the same WASP as he talked about yesterday on the technical for fishing, but obviously with the hydrographic slant and the hydrographic sensors and hydrographic setups and the little bit extra time and energy you put into making sure that the performance and the accuracy is to that next level. So we're going to, that's the sessions for today. We've got a reasonable number of people. Good day. Hi, how's everything going? Good to hear from everybody. So thank you very much for coming and joining in. There's a bit of crossover, like I said, but there's a different slant on how things work differently today. So I think we'll just get going. I don't think there's need for anything else. Good morning. Good morning from Canada. Good morning from where all over the place. It's good to see. Okay. So here we go. So the wonders of sports fishing. A variety of different pictures here. A little bit of a Kiwi slant, if I may say so, and the success of sports fishing as always. So it is still about being precise and searching for fish habitats and finding the fish habitats, then finding the fish, then targeting the fish, deciding which fish you're trying to chase and target, and then catching the fish. So it's all part of the same process. The secret spots in sports fishing are just as well preserved and protected and desired, I guess, as they are in commercial fishing. They're probably done for quite different reasons, but at the end of the day, there's still the secret spots. You're targeting it in a different way. Generally speaking, in individual fish targeting rather than schools of fish targeting, but not always. And you're obviously using completely different gear when you're fishing. So once you find the wreck and the reef and the structure, you want to know where the crevices are in that reef, where there's a gap through the reef, which way the tides are running over that reef, which way the wind's blowing, where you're going to be able to position yourself for maximum benefit over that particular reef. The tides and the currents have a big impact, obviously, on the gear and the equipment that you're dropping down. So there's a lot of impact into finding your position and finding that. The the concept remains exactly the same. WASP has got a very good capability of finding unseen rocks, drop-offs, pinnacles, holes, whatever it may be that you're particularly finding, and has got a very quick way of mapping those, retaining that history for forever. It's yours. It's your map. You're generating your own map. What you do with your map is up to you. The quality of your map is up to you, and how much effort you put into that, and then you're utilizing that map over a growing amount of time. Now, the use of whether you're using that with time zero or whether you're using that with CDX remains the same sort of personal preferences as there is with most things. Time zero professional obviously has a huge benefit in the multi different things that it does as a software program, whereas WASP CDX just focuses on WASP and the mapping side of things like that. So it is a single function rather than a multi-function bit of software, if you like. The habitat, the environment, the building that understanding. I think in the deep drop type style fishing, then the habitat and the environment, the pinnacles, the rocks, and everything is very obviously a very, very important part of that habitat. But likewise, very frequently, what's on the seafloor has such a significant impact on the whole water column right through to the surface. So it's not an accident that a lot of fish species or schools of fish that are mid-level fish, pelagic fish, still hang around where there are rocks or features on the seafloor. It's not an accident. These things happen. The whole food chain of the various little bits that come, that maybe the tides or the currents are washing up from rocks and coming up to the surface, and there's a lot of things that happen in that water column that come all the way through. Maybe it is the other way. Maybe it's the feeding of the fish at the surface that is dropping down to the floor and generating more activity on the seafloor. So that whole water column is, in one way or another, most of the time linked, and therefore that habitat and understanding that seafloor is very, very crucial. I think there's a lot of stories about a North Sea story, which isn't a sports fishing story, I'll apologize, but the North Sea story about the gas pipes that are buried a meter, more than a meter underground in the North Sea. And that has a very minor slight change on temperature of the water, and that means that fish are very commonly found above that. So understanding what's on the seafloor has quite a big impact. Obviously, if it's thousands of meters deep, then your understanding of that is not so important. The mapping of the fish in the water column, and the WASP capability of doing that, and to be able to provide that in very deep and very wide coverage is another crucial understanding where even if it's not on the seafloor, where the habitat of the larger fish are going to be, and understanding where the school of bait fish or the school of smaller fish are, where the thermoclines are, and mapping out that to understand that environment or that habitat. It's a crucial part of all sports fishing. Habitat is where it's at. I like the saying, I hate to say it. Captain Swish is a sports fisherman Well, is he a sports? Yes, he's definitely a sports fisherman, but his desire is to catch enough fish to feed himself and the family and the neighbor and whoever else comes begging to him for fish, and make sure that he gives enough back, I guess. So his concept definitely is about understanding that habitat, understanding where that one big fish is going to be, where the feeding habit's going to be, where they come back to hide, where they protect themselves, where they're safe, where they're having sex. I don't know, whatever the fish story is, and understanding that habitat, and trying to draw the bigger fish out of that habitat, and the ways of positioning yourself and burling fish and so forth, is all comes true across pretty much every sports fishing story and discussion and experience I've had anywhere in the world. A lot of this whole discussion comes back to it, so it becomes a very important factor for sports fishing anywhere in the world. It is finding the habitat first, then finding the fish using fish finder or sonar, or a mixture of WASSP and fish finders and sonars and so forth, and then targeting the fish and then catching the fish. So the process continues through, and finding that habitat of fish is the easiest way to where you're likely to find fish is really reducing the amount of time it takes you to find the fish that you're particularly after and targeting that for that trip. The benefits, the multi-beam benefits. For many of you, I apologize that we've been through this slide again a few times, but it draws home that a narrow beam single beam sounder gives, in a single beam focus, the best way to see the detail of the seafloor. It gives a fairly narrow understanding of the water column. So it comes back to being a very, very good way of seeing what's directly below you, but it misses out a significant amount of the detail along the way. And then a wider beam, single beam sounder, gives a much better overview of what you're able to see, a much better view of the water column target. Works really well on flat floors, but misses a lot of the detail of the seafloor, and still has a limited coverage. And then the multi-beam has the benefits of lots of little narrow beams. So the very narrow beams, and those very narrow beams provide you the detail, the definition, and then because you've got so many of those, then you get the coverage, and you're able to see the full picture, or a much wider picture of what you're looking for in significantly more detail. And that's the major benefit of multi-beam over any other sounder. Once we've then taken all that data and we've built all those data for those pinpoints, then we're able to map that into the 2D and 3D mapping, and that's the next step that definitely works in your favor. I've just realized, looking at this picture, that this portrays that the multi-beam is 4.5, whereas the picture probably shouldn't do that. It is very much port and starboard, as I think that you all understand and know, but I just realized this picture portrays that the wrong way around. So once we get all this data, if we have a little look at the different coverage, if we take some examples that we've done. So if we looked at a single beam with a narrow, typical 200 kilohertz single beam echo sounder. A single beam narrow. So we're talking about the footprint of that being around about a 9 square meter footprint and 100 meters of water. And so you're getting effectively one data point per ping back from that 9 square meter footprint. And that can be set differently in different sounders, but essentially is generally the shallowest point that footprint hits. If you go into the wide print, that footprint becomes much bigger. The downside of that footprint is that it's a much bigger area that you're getting that single data point back from. And whereas with the F3X and that sort of depth water, that footprint is smaller, so it's a much more accurate footprint. And the deeper the water goes, the much more obvious those differences become. Now, if we take that into how much coverage we get, how much sea floor are we picking up, then your coverage with WASP is many times better than any single beam. So you're getting the benefit of the single beam and more coverage than the Y beam. So you're getting the detail or the definition of the smaller footprint, and you're also getting the coverage of a multi-beam. So your coverage is very extensive. So that gives you the best of both worlds, if you like. So if we do this, I know that there's many people that have sold many and worked with DFF 3D and other single beams, and this is, please be reassured, this is a comparison type exercise. I'm not knocking those products. Those products are very good and got them very good advantages. I just need to try and portray the differences, and the differences, if we look at this in a numbers game, if you're a numbers kind of person and you're looking at the ping rate, the maximum pings per second, and we look across the different products. Now, the WASP hasn't got any more pings per second than a typical single beam. Okay, so now we've got a reasonable amount more pings than the DFF 3D per second, but the real difference is WASP has 224 data points per ping, and so we're getting readings back on the Echo 4 every ping, and those pings could be up to, like it says, 48 pings per second. Now, the pings per second, as with all sounders, well, with WASP definitely reduces according to the depth you're in. The deeper the water, the less pings per second, because it can't, the understanding where that data comes back and the frequency of that data coming back and the amount of data you can get in shallow water, you can send out a lot more pings and return that and work that through. So talking about those detection points and the amount of detail and definition is very key, and the numbers sort of tell big numbers here compared to the other systems. And so the numbers all sound very good and well, but when you start to put it in a picture, what does it mean? And so we've done some comparisons and tried to do a recording at the same place at the same time with a DFF 3D versus an F3. It's shallow water, it's calm conditions, it's good conditions to operate in. So it should be giving the optimum for both systems. And being able to have those extra data points mean that you get so much more definition and detail back in the WASP product, and the detail that you're potentially looking for is significant. Now, DFF 3D has a significantly better picture than if you block that together with a single beam sounder. So it's a progression of the products through the life. So there is no bad products there for what they are doing. There's just a progression of products through the range, and I think that's the way we like to look at it. ENL, WASP's parent company, ENL, is a company that sells significantly numbers of DFF 3Ds in New Zealand and have some really good customers with that. So it's not that we are knocking DFF 3D at all here, please. So the target habitats we talked about, we looked at this. These ones are less probably important, probably for sports fishing, but the principles remain exactly the same. It's a matter of trying to understand those little drop-offs, those little pinnacles, and they may only be a foot or 2 feet, and it's 300 or 400 feet of water. It may not be very much at all, but it provides a hiding spot for fish. And it's a matter of trying to understand the shape and the structure of those and to get a better picture of where they are and position yourself in the right place around them. So what I wanted to have a quick do is just yesterday, day before, maybe, Matt Watson, who is a TV fisherman, has a TV show in New Zealand that's seen quite extensively around the world, actually, as sports fishing for all sorts of fish in New Zealand. He posted something on Facebook just the other day. So let me try and get this here so you can see it. Sorry, give me a second. There we go. So if we play this, you'll even hear what he has to say. Wait a sec. Let's go back and do this again because I put it on mute. Doesn't help, does it? So I think, excuse me, sorry, let me just get rid of this so we can move back to where we were. So I think probably Matt Watson explains that significantly better than I can. But I think it comes back to that. I think one comment he said in the middle there, that there's no way, you can never have too many sort of fishing points. Okay, sorry if you didn't get the sound quality on that. Sounds like it didn't quite work as planned. But hopefully, yeah, hopefully it gives you an idea. The links here, or as he advertised that it's ultimatefishing.tv if you want to go and have another look at that at another time, and we'll try and embed it next time so it works a bit better. I thought that would be an easier option, but obviously not. So I think the principle remains exactly the same. It's we're packing up, we're fishing, we're operating somewhere off, we're heading somewhere else. We're on the way to our favorite fishing spots. We're constantly mapping, we're constantly on the lookout for that new little bit of ground, that new little bit of area. And with WASSP, your coverage is so much wider that your chances of seeing that new little spot are significantly higher for whatever that happens to be. So I thought that was sort of quite timely that was posted this week. Thank you, Matt. And yeah, he has, for what it's worth, he has Facebook pages and all the social media and all the websites, and a significant amount of feedback on that. As you would see on there, we have WASSP running on a PC behind the dashboard, and then we're using the Fruno TZT touch control as the display, and we're using the touch control fed through the TZT and being able to control the WASSP. So gives a very good way of using WASSP on smaller vessels. I think later in the presentation we've got a couple of pictures of the transducer placement on that boat. So this video of the backscatter, and the backscatter is obviously, for any type of fishing, has got some major advantages in how that backscatter works. And using this particular one, obviously using backscatter with TimeZero Professional. The way TimeZero Professional does the coloring and gives you the flexibilities in the coloring, gives it a really good way of displaying and highlighting the differences between the different hardness and softness of the seafloor. Backscatter and WASSP is obviously a reflectivity measure, which is slightly different than backscatter in some of the single sounders, but it's still very, very accurate at providing you the change and the movement between softer and harder ground, and the various different stages between slushy mud through the hard rock, and being able to map those in different scenes and being able to utilize that along the way. So I think that the way TimeZero presents the various different coloring options is a really, really positive way in showing those details. The discrete colors in that particular mode, giving you quite a lot of flexibility. I think to mention in there as well is that a lot of that is how you set up your display. So the coloring from one vessel to the next vessel is not necessarily exactly the same, and that's a mixture of both the hardware, but also significantly to do with the way the software and the display is set up. So you get quite a lot of flexibility in how you run that display. So when we look at the ideas of the precision, some more pictures of how the targets that you're trying to find, the understanding here of the fish being stacked on one side of this particular wreck, in this case, and understanding the detail and the shape of that wreck and where the fish are. And I'm sure that as the tide and the currents change and the position of the fish on that wreck will move accordingly. Maybe the wind, maybe the tide, maybe the wind changes, has an impact on that. And different times of the year, the month, whatever, the moon phases, whatever it happens to be, will have further and further impact on that. But identifying that true shape, and therefore being able to position yourself fishing in the right place, obviously has significant benefits in your fishing. I think the water column and understanding the water column targets is very, very crucial. Being able to use the slider basically on the color arrays, slider on the water column targets, to be able to display just targets of certain stronger echo, stronger return, and the target strengths, and therefore being able to understand what you're more likely to be looking at, and just to run that slider back up and down and being able to see where there is some returns that may even be thermoclines, or may even be heavier sets of krill, or whatever the water noise is, and then being able to drag that down into the much more bigger fish targets, and being able to see how that whole habitat coexists together, I think is really, really important with the water column targets. And I'm not sure. I think with all these controls, you can set the amount of time that you look at the water column targets, so they don't clutter your screen forever. You can just say, I want the last 5 minutes, or I want the last few hours, or last few minutes, whatever it happens to be. Coming into the product mixes then, and so having understand a little bit about some of those major benefits of Freno, we have the product mix between the different hardware. So in sports fishing, the depth of most of what you're fishing is about is really the main key decision maker. There's a few other elements in there, but the main key decision maker is about the depth that you want to be fishing in. Sorry, we're all metric, so we're talking 400 meters, 1200 feet, thereabouts, and that sort of maximum depth. But as with all echo sounders, you probably want to look at sort of 80% of that maximum depth being the sort of the top depth that you want to be spending a lot of time fishing at. And with sports fishing, it depends. You may only go out to the deep water very rarely in a year, or very rarely ever, and so it comes down to matching that where you're going to get the maximum benefit. And I think the other option is with the understanding and mapping the water column, then seeing the sea floor might not be everything you possibly need for that type of fishing. So it's understanding, getting the maximum out of the products, out of the option that you need, and trying to fit that into I guess the budgets and the requirements that are available. So the F3 and the F3X are with the higher frequency, smaller transducer. Again, our center frequency can be shifted from 120 up to 200 kilohertz. There is some limitations at the higher end of that frequency, but we can find an optimum frequency that suits every boat and every type of fishing. Ultimately, the higher the frequency, the more detail, and the lower the frequency, the more depth, as a general rule of thumb. But there's a variety of other factors coming into that, and we're working with chirp, so we have plus or minus 30 kilohertz of chirp in the higher frequency, and plus or minus 20 kilohertz in the lower frequency transducer options. and the swath coverage is 120 degrees, which is around about 3 to 3.5 times the depth operating there. So moving on to looking through a little bit of the specifications and different options. I think ultimately there's a lot of similarity across all of them. The ping rate on the higher power is slightly slower than the F3, but the data points remains exactly the same. The beam angles and all the transducer functions remain the same. I think that one thing to mention here is often with the lower frequency transducers, there's a reduction in performance in shallow water, and that remains true with WASSP to an extent, but that reduction is significantly less than you would expect on a traditional sounder. And the main reason for that is that the beam size remains exactly the same whether you're with the higher frequency transducer or the low frequency transducer. Traditionally, a low frequency transducer ends up into a much bigger beam size. And so it's a mixture of both the beam size and the frequency that changes the performance in shallow water. So going with the lower frequency transducer has a very minimal impact on your shallow water performance. But with the lower frequency transducer, you do need the higher power processor. So you do need the F3X, the DRX46 model. I don't think there's anything there I need to add. There's different specs and the different availability of that. I think that looking at the transducers, the tank mount, the pocket mount, the sea chest mount transducer, in sports fishing boats, often we find that these are cut into keels or built into keel mold type configurations, and rather than have external dams or external fairing blocks or blocks that they're mounted into. So that tends to be the way in sports fishing. Although it's not unheard of, they still have an external block. And then we have the wideband fairing transducer, which is definitely the easiest way to install that on any fiberglass type boat, and is by far the easiest way to have that externally mounted. It's not always the optimum way, and depending on the speed that vessel wants to travel at, it may not be the perfect solution on a smaller vessel. But it is definitely the easiest and cleanest way to mount a transducer on sports fishing boats. I think that. And definitely the easiest to retrofit. But it's not, like I say, it's not necessarily always the perfect way for all boats, and where there's a place that's available and where having the transducer externally mounted is possible, particularly with trailer boats, is another question as well. So finding that perfect place and that location for a transducer has its challenges. It's very doable, and it's not unusual. We have many vessels less than 30 feet with transducers installed all around the world in various different boats, and it's very, very possible to do. But there needs to be a little bit of work together to try and make sure that transducer, that space and time and is given to positioning that transducer in the right place to maximize the performance. And for a lot of the smaller boats, this may be a big part of the investment of the boat. So it's not of the whole boat, but maybe a big part of the investment of the various different equipment that boat is having. And so it needs to be given that sort of respect and given that credibility to be given the right amount of time to position it in the right place. And then when we come through into how we display, so we have the WASSP CDX, the PC software type scenario, which has like a standalone WASSP, if you like. And that is, for some people, it is a perfect scenario. Many people like to go to the Time Zero Professional program. And Time Zero Professional is the multifunction display that WASSP works with and interfaces with brilliantly, and brings everything else into that same picture. Many places around the world, the Time Zero is head and shoulders preferred above any other option. In other regions, other individuals, they have different preferences. So how you like to go. Now, the functionality with bringing WASSP into the NavNet TZ Touch 3 on the 16 and the 19-inch multifunction displays is something that we're doing more and more frequently. I think that there is this is a very nice way of setting this up on a sports fishing boat, and to be able to have the multifunction displays and not have a separate PC panel that's running WASSP, and to be able to bring this into the same display, and also to be able to use the touch controls, which are so very popular and make life much easier from an operating point of view. And so we basically have a little PC that runs in the background and is connected to the Fruno through HDMI and also through USB port to give the touch controls. So it's quite a simple setup and configuration, and has a lot of success. I think that, as with and has just as many benefits and pitfalls, I guess, as any touchscreen on any display. This setup here is what's on Matt Watson's boat. So and operates that. So he can have sounders, he can have the separate chart plotter that's in the multifunction display, and have the WASSP operating all at the same time, side by side. And I think that gives that flexibility. So we have a little clip, I think, that we saw this a little bit with Matt Watson. Okay, I'm just told that the sound is not coming through again, so I'm not sure what I've done wrong. But basically, so hopefully we've seen that. I think through here there was a couple of options in there that were highlighted. So the color arrays was used by Nick's fingers, and he was showing the color arrays to show the fish targets coming up amongst or over this little gully that's seen. I believe that looks like it's in the backscatter picture there, and showing the various different schools of fish that are on the sounder being shown or displayed by adjusting the color arrays on the water column targets. And this sonar type picture here, he's showing where he's set up on this particular boat, the 3 beams to give him his sounder picture. So the flexibility of being able to focus beams to the port or starboard or to whichever side you want to, and being able to see that the center beam here is the beam coverage from this beam number 3 here. And just like a normal sounder, it is what's current and the history behind you. And being able to see that school of fish much stronger in here, and not being able to see much of that into the other beams, is also illustrated from that sonar view here. So you get quite a lot of obviously control out of where you're operating there. Just as a mention here, the beams that are shown, everything's recorded always, but it's a matter of showing what you want. So you can change both the width of these beams and also the distance from the center. I think that was shown very early in this video too. Yeah, you've got the angle to the port and starboard, and also the beam width to control. And being able to get that target strength signal from the sounder, and then being able to use that same target strength information and mapping there. Excellent. So comes into the systems, and I guess the systems on sports fishing boats, you have generally less. You have a lot less space to play with. So there, everything needs to be truncated a little bit. Okay, sorry, there we go. So you have a lot less space to play with. So but you've still got to be able to fit everything in. The PC specification now becomes is no longer, well, I guess when we first came out, it was quite a high spec PC, but over time, the PC technology has improved. So therefore, we can fit into smaller and smaller PCs. And the little Nook type PC, which is very small, I saw a little preview of a Hatterland one that might be coming out to the market relatively soon, which looks like it's a perfect scenario as well. So there's a variety of different PCs that are nice and small and will be able to hide in behind the dashboard or on smaller sports fishing boats. And as we were saying earlier, instead of going directly to the PC to a display touchscreen, we can go to the TZT type configurations as well. So I think that gives that display capability in here with the displays and the touch control. You can obviously still have your trackball and your other controls off that PC, and if you have a preference for doing that instead of touchscreen, then that obviously remains an option. Sorry. Then we have obviously our DRX, our processor, our transceiver, and then that feeds in with the motion sensor and the satellite compass information that comes into that. Obviously, that goes to a ship's earth, so we need to get an earth even on small sports fishing boats. But generally speaking, there's a way of means of doing that. There are very, very small earth plates that are available, which have a very minimal impact. So potentially that might be a last resort, but often there's another way of finding earth on smaller boats. The satellite compass and the motion sensor, in many ways, on a smaller boat, almost become more important because a smaller boat bounces around, pops around a little bit more on the sea surface than maybe a big boat does, and the rapid change is potentially faster than on a bigger vessel. So I think that it is important that no sort of shortcuts are taken in that. But again, it comes down to that requirements. If the requirement is for a sports fishing who really just wants to map water column targets and is not so fussed about the seafloor, then the accuracy of being able to do that is somewhat less than being able to map a detailed seafloor and sea rocks at very deep water. So there is, as with everything, there's a sliding scale of your performance versus the satellite or the sensor information that you input into WASP. Running with the WASP V123 and the IMU 038 is our recommended solution. There is, as always, a sliding scale of what level of sensors that you want to use on your particular vessels. I think if you're mapping the seafloor, particularly from a bathymetric point of view, and you really want to map those little drop-offs and those little rocks, and you want to be able to go over those every trip you go over and not have that rock look like it moves or look like it's changed in position, then the accuracy of your sensors needs to be very high. However, at the other end of the scale, if you're just mapping backscatter and having that line of shift between soft and hard move a little bit each time you go out and map it, is not much of an impact on you, or you're just mapping the water column targets, and the positioning of those fish, whether they're a meter port or starboard, doesn't really make much difference to you as long as the fish are roughly where they are, then the requirement for sensors is less. And so I think if we think about sensors as a scale of the higher the performance my sensors are, the more accurate my WASP data is going to be, then I think that's probably the best way to configure that in, and build that same expectation with customers. A lot of the pictures and the stuff are from real customers, real use with their own sensors and their own setups, and a lot of what we publish has defects in it, and those defects are very often down to the sensors that are being used on those boats. And if you look at the high-end survey type applications, people can spend hundreds of thousands of dollars on sensors to make that data cleaner when it comes out of the system. So it depends on where that requirement is and trying to get that balance through. I think so in the package system, on this package down here, we obviously have the higher powered DRX, the DRX 46. It's used with the F3X and the F3XL. And that whole system remains exactly the same. So you've still got the sensors coming into the same DRX, same processor transceiver, and you've still got your separate PC running your control and display software, whether that be Time Zero Pro or whether that be CDX. And so you've still got that same configuration and setup. And then your transducer, the transducer of choice, the bigger low frequency transducer for the maximum depth, the smaller higher frequency transducer, or the fairing transducer, gives you the various different options that are available. There's a couple of questions there, but I think they seem to be answering themselves, so I will leave that out for now, if you don't mind. Come back to it if that needs to be raised. So coming back to some more pictures, some more understandings of those, understanding that those little small drop-offs. So here we have a 2 foot? Yeah, 2 foot. 2 foot change in the depth over a little mound being shown in 358 feet of water. And being able to see that and pick that up and showing that both in the color, but the color is down to the settings that you have on the display. So the color depth is showing on the display. So here we only have the colors showing the difference between 10 feet of water. So this So often we will have people talking about how do we do those colors. If you're really after some really small changes in that differences, making those colors change colors radically between very narrow windows of depth is a really good opportunity to do that. And sometimes that's something that you can do when you play back quickly, and sometimes that's something that you can do live. But often when you do this, then a lot of the other data disappears into the grayness because that color range, to highlight that color range. So being able to spot these as a difference as you're going over is not only difficult for the WASSP to do and for any sounder to do, but it's doable with the WASSP. But as an operator, they've got to be a reasonable amount of awareness to be looking for the right thing here. And to be able to use this line across here and highlight that change is quite significant. Just like any operator of any sounder or sonar, the eagle-eyed and the guy that uses it, or the girl who uses it often and frequently and is looking at it all the time, will notice that change a lot earlier than the rest of us probably will. So I think it's I think that this small change sort of highlights that difference, and that it's experience and using the equipment that allows you to start to pick up these little differences, because seeing them with your own eyes is not much easier than the WASP seeing them themselves. We've been through this. Whoops, duplication. So understanding that seafloor hardness and the shape and the structure that works around that is very, very key. And being able to see that where that hardness goes, where that flows through, and the differences around that pattern. I think here is the being able to understand that difference and look at that from a 3D picture as opposed to a 2D picture. A 2D picture that doesn't look that necessarily that exciting through into a 3D picture, which is obviously showing zoomed in and showing a significant change in that. And the reality of that mound, which is what, 3 odd meters, 3 meters thereabouts, and 40 out of 40 odd meters of water. So it's not a huge Mount Everest mound, but it is obviously there, and being able to see that in the sounder clearly as well. And the sounder is obviously showing that it's attracting quite a lot of fish, that small mound. It's building up that database, building up that knowledge, and I think that what everybody, well, I don't know what all of my sports fishing learning and knowledge is that you're building that up in your own head from a sounder. You're developing that 2D, that 3D map. You're trying to understand where those rocks are, the shape of those rocks, and why that structure is from your sounder image, and being able to try and interpret those onto the rocks, and using various different markers and waypoints, and to highlight exactly what's happening there, and to be able to see in WASSP the gullies through the rocks, not just be able to see that that's rocks, and be able to see that in a 2D and 3D and interpret that significantly easier. I had several people ask me about how easy WASSP is to interpret, and it's the impossible question. There is no simple answer of how easy it is to interpret, but because it is very similar in many ways to Google Earth and to Google Maps and those sort of things, and it's giving you a 2D and a 3D map, then more and more people that have limited experience with sounders find this much easier to interpret than even a traditional sounder. So it depends on that person's background, that person's experience, that person's knowledge as to how easy WASP will be to interpret. But for many people, it is much easier than many of the other tools available. I think that understanding even that soft ground, that sort of obviously not necessarily a gully, but it's a soft bit of mud that flows through here, and understanding where that is compared to everything else becomes such a crucial aspect of what WASP is showing, and not just the hard bits and the high bits. So we've got a reasonable amount of pictures here. Let me just go. I'm going to skip through here for a second, if I may, and look at some installation examples, because I think this becomes the next stage of importance. So this is Matt Watson's boat. I can see that because he's changed his outboards. Don't tell anyone. And seeing that, but I think that the picture underneath of the amount of effort and energy that we've all gone through into finding and creating a pod for the transducers, and being able to utilize that pod for the transducers is a crucial aspect of how important that the sounder has gone into making this boat perform. And it is a reality. But having said that, it's a reality for a lot of these sports fishing people that are that passionate about their fishing. Then it's something that they will put a huge amount of energy into making. There's a huge amount of research goes into the products and the performances about how to do that. So I think that where there is a passion to make this work, there is always a way to make these sort of things work. And the more feedback and answers and the responses that we're getting from WASP users from a sports fishing point of view is proof that the benefits or the enjoyment for a lot of people is in the hunt, and having the right tools for that hunt is a huge part of that for them. And so therefore it's well worth doing. That's a picture of that on the trailer. It's even designed perfectly in to make sure it doesn't get stuck in rollers. Yes, it's aluminium. Yes, it's a New Zealand traditional boat, and not quite a fiberglass American style boat, but the principle and the opportunities remain the same. I guess having spent last week, the week before, at Fort Lauderdale Boat Show, and the amount of what's the terminology? I've lost the terminology. The amount of revs and the speed that a lot of these boats are needing to do, and the planing functionality that's going into them, and the various different hull shapes mean that there's a lot of limitations on positioning for WASP. But then I was at a catamaran at the end of the trip, and they had a bed in a flat part of the hull, and the right in the aft of one hull, and is a perfect position for transducers. So there's generally a way to find the right place for the WASP transducer. And I think the reality of a WASP transducer, you need to take into account that if it needs to go forward on a vessel, that's absolutely fine. But you just need to take into account the aeration possibility, so that it becomes a speed limit on how you can make that work. Thank you very much. I'm glad to hear more aluminium boats, maybe than I saw in Florida. Not so many aluminium boats in Florida. We have. We will go through a few of the installation type pictures, and we will make a more concerted effort to make sure we get some more installation photos out to everybody, because it is a really important part of this. And likewise, we need you guys to share your installation photos with us so we can share with the rest of the world, because everybody is struggling in the same way to try and get ideas for installations. I think Justin, in his presentation about super yachts, has got some nice ideas of installations and tenders, because obviously an installation and a tender for a super yacht is often a relatively small boat, similar size to a sports fishing boat. So there's a lot of crossover we can learn from those sort of things as well. So yes, but likewise, please share with us some of the installations you're doing. Where are we at? This is mapping at high speed on the same boat. It's 24 knots and still mapping that quite nicely. So the speed of the boat is that the WASP will work at. That's the next question that you often get. What speed can the boat work at? Is down to the transducer installation. The location of the transducer and the amount of fresh, clean water that goes across the surface. Obviously, the faster you go, the bigger distance you get between each ping. So therefore, you're losing some of that data, and you're not necessarily getting the most. Sorry. Go back to this. Wrong button. Pardon. Yeah, so you lose some of the data. This is a white pointer installation. Another vessel. These guys have a dedicated display, and some of the feedback on there, some of the stories and the pictures they've sent us. And some of the mapping they've picked up on there. Working in conjunction with sonars, in this case, using their own displays, having sonar on board this vessel as well. The transducer in a custom keel tank type scenario. That looks exactly like it's on the center line. The picture's a little bit deceiving on the angle, but yes, that's on the center line. So having a separate pod or keel tank, whatever the terminology is that we want to do for the transducers, and positioning of those transducers in there. There's a couple of, I won't show the video on there because it's more about what he says than what he's showing. I think we talked a little bit. This is on a Riviera 48, 52, something, can't remember, and using the fairing transducer and the install of how that worked. Rather than for years and years, I think this guy has built multiple different tanks over the years for installing transducers in, and he was very happy to see that this worked in and made a way of making this fit and installed significantly quicker than he expected, and very, very cleanly, and the performance at speed as well. Mounted just here, if that's not very clear to see. And then bringing that into Reg 64. My apologies. And this is another. Sorry, this is a different Riviera. The last one was Riviera as well, and being able to build that transducer into another pod. We will continue to pick up more and more pictures, and this vessel has also got, sonar. I think here we can embed some of this video in here. So I think it becomes important if you guys can continue and help me out by keep sending me your videos and your footage, because it's very, very important that we all learn from each other, and the more we share, the easier it is. For us all. So another scroll through another vessel. Australian, no Noumea, sorry, my apologies. And the setup here. So I guess this is going through quite a lot of those examples, and we will make sure that we get more examples going out. There we go. So I think there's a few questions back and forth about the installations, the speeds. I think the competition. Dave, you're winning at 41 knots, eh? Nobody's able to beat 41 knots operating on a WASP. That's good to hear. I think 27 knots, I would have thought. I quite like that. 30 plus. I think we need proof, guys. I'm not sure. We need proof. Excellent. So I think that is really all I wanted to sort of talk through on the sports fishing. If there's any other sort of questions. We have proof at 27. Share. So yes, if there's any more questions or any more comments or anything else that people can would like to contribute, that would be really, really good. Otherwise, we're going to move on. I think we've got about a 15-minute. Am I right? About a 15-minute sort of gap until we move on to the super yacht section with Justin, who'll be with us. So we'll monitor this for the next sort of 15 minutes, unless there's anything that we need to, anybody say anything that I've desperately forgotten and we desperately need to go over more time on. Otherwise, we'll have a look and we'll answer questions over the next 15 minutes, and we'll be back in about 15 minutes. Thank you very much, guys. And I'll see you tomorrow. But we've still obviously got a couple more presentations today as well. So next is the super yacht wireless discussion from Justin, and then after that we have the more technical survey application use with Andrew. So that's progress now. Yes, thank you.
Okay, here we are. Let me get this going, guys. Okay, I hope everybody's ready for my presentation of today, which I'm going to talk about superyacht and cruise ship navigation using WASSP. And in this case, it's about using wireless WASSP, which is a new application derived from the WASSP multi-beam technology with additional features to it. And I'm going to show you guys what it is, what it does, and where it's been useful for. Okay, well, first of all, a very important point on this presentation here, where we start with, is basically the situation around the world with the oceans is we all know that 71% of our planet is covered by global ocean. And this global situation with the oceans, of course, is very important, that the oceans are central and vital to the life as it exists on Earth. However, but only, the thing is that only 19% of our seafloors of the oceans have currently been mapped. So that's very, very little. Now, there is a lot of improvement. There is a lot of, let's say, possibilities and also initiatives to increase that number in a short period of time or in the coming period, the coming years. However, 19% is still very, very little. And actually, what I believe and what I understood is that the space, the planets are mapped better than our Earth oceans. So just to give a bit of an idea. So having said that only 19% of our seafloors have been mapped, and it doesn't really mean that they've been mapped in a proper way. It can be mapped in a very simple way, but at least we know of 90% of our oceans that we know some sort of depth information and that. So now we all know, we're all working in the marine industry, so we all are aware of navigational charts. Navigational charts in the existence of paper charts, of course, previously, and now slowly been taken over by electronic charts, ENCs, and of course ECDIS systems for official use. And then of course you have the various non-official electronic charts. If we talk about official electronic charts being used in ECDIS, so ENCs, these official digital charts are a replacement of paper charts, and have can be used on certain occasions. If we look at an example like we see here of an official ENC being used in an ECDIS system, an electronic chart display system, if we take the same area using a non-official navigational chart, in this case, it can be a CMAP or an avionics chart, we can see that the information is very much the same, but quite often these non-official electronic charts include some more information, some additional information like user edit information. It can be information added by the manufacturer. So in principle, in base, the information is the same. However, there is some more information there. Now, this is information that you will find in most areas where there's plenty of navigation going on. There's where traffic is going. An example what we see here is that's probably you see the shipping lane, so there's a lot of traffic here. So these charts are properly made. You can see all the depth contours and the spot soundings and things like that. So this is a proper chart. However, if we go back to the discussion that I just mentioned before of only 19% of our global oceans being mapped, you can imagine that in certain areas around the world, the chart information is basically non-existent. So you will see a chart with almost no information. So having said that, we know that a certain type of vessels are actually exploring around the world. And these are mainly super yachts of wealthy individuals that have very big yachts that can cross around the world, the globe, cross the oceans, go anywhere they want. And the same thing, more and more, we see this with cruise ships going. The cruise ships are not anymore just going to the usual milk run, as we call it, Mediterranean, Caribbean, things like that. What we see more and more often is these cruise ships and the super yachts are starting to explore, going to areas anywhere around the world, beautiful areas like we see here. Now, like I said, a growing number of these vessels are exploring into these new areas, but these areas are exactly, or very often exactly the same, the areas that are not mapped. And the reason is because there is generally very little traffic. So, there's never been any real need to have these areas mapped. However, if these large vessels are going into these areas and there's no charting information available in their official ECDIS, nor maybe on a paper chart, or at last resort maybe a non-official chart, then of course it becomes really difficult and also dangerous to move into these areas, because what happens if a multi-million super yacht runs aground, or a large cruise ship with a lot of people on board runs aground? Then of course that's a huge problem. So having said that, what we have basically done is, if you look at a chart like this and you're in an area with your yacht or your cruise ship and there's no information whatsoever available other than your land contours and some dry or shallow water lines, then of course what can you do? You get into this area. So there's a couple of things you can do. I mean, you can say, well, maybe we'll just turn around and go back. We don't go into this area. But then of course, if you're a wealthy yacht owner, you want to go into exclusive places. And if you are paying a lot for your cruise ship travel, you want to see exclusive stuff. So that's not maybe an option. And the other option can be to use all these vessels have tenders, small additional vessels that they can use for various operations, going to shore and driving around and things like that. So what you can do is maybe put somebody at the bow of the tender and just read out some, if you can see some rocks or nasty structures that may harm the mothership or the yacht, and call it through on the radio saying, don't go here, don't go there. But that, of course, is a very, labor-intensive operation. You could maybe think about using a single beam echo sounder, your echo sounder that's on the tender. But then again, that will just give you a few depth points. And between those depth points that you're measuring, there could be this nasty rock or, some kind of reef that can still be super dangerous to your navigation, safe navigation into the area. So really the option can be to mount a WASP on your tender. And in this case, what I'm talking about is the wireless WASP system on your tender. So the picture you see here is one of the tenders, one of the recent installations we did, where we have the WASP portable system, and then you've got a screen with the mapping. And basically the way the WASP on the tender and the yacht part together work is this way. We have the mothership, as we call it. We call it the mothership because it can be a super yacht, it can be a cruise ship, it can even be. We have also naval customers. So the Royal New Zealand Navy, for example, are using the wireless WASP system for certain operations. It can be virtually any type of situation where you have a larger size vessel wanting to go into a certain area and just basically not possible, then using a smaller remote vessel like a tender to map the area for you. Then, so basically what happens is the tenders, which you can see here, is creating the map. So you're basically using the the WASP on the tender as you would use a WASP on any other vessel. The real-time mapping of the 2D and 3D seafloor data is showing on the screen on the tender, but in this case, in real time, this information is being transmitted via Wi-Fi, via link to the mothership. So in the bridge of the mothership, the captain, the bridge crew can actually see a real-time image of the tender moving back and forth into the chart area. And that's where it says here, so the information is instantly relayed from the tender to the yacht. So you see the tender in real time moving. At the same time, in the bridge, they can also see their own position, the position of the mothership. And basically over time and very quickly, because we're using, of course, multi-beam technology, you're mapping a very wide area very quickly. In the bridge, they can see a map being built up in real time, and based on that, they can plan their route into the area for safe navigation, basically. So the idea is tenders doing the mapping. This is a bridge of a super yacht. At the bottom, you see the WASP screen, and that's running on a dedicated computer. In this case, we're showing it in our CDX software. So here on the display, you see the mothership, you see the tender, and the tender is just moving back and forth, painting the area. And in this example is very good. You can see, the limited information you have from your basic electronic chart and the amount of detail you're getting from your multi-beam system. Now, of course, as I mentioned before, the benefit of using multi-beam is that you can basically, you catch any kind of dangerous situation. So in the picture here, it can be a rock structure or a peak or a reef or something like that, that could be hugely dangerous for, the largest ship, the mothership, to go into that area running against it. If you're using single beam, you may miss it. If you're using WASP multi-beam with, the number of beams that we're using, compared to, for example, a leisure multi-beam system, because of the number of beams being so big, you basically won't miss any detail. At the same time, you're also mapping a much larger area with more detailed information. So, if you don't have, like we said before, you have the area without any information, but you have your WASP on your tender. You've got the mothership waiting to go into the uncharted area, not knowing at all what's going on. Well, what you can do is, send your tender out in front of the yacht, around the yacht, and start mapping the area. So basically just making a painting with all the details of the actual area in front of the yacht, where the yacht wants to go into, maybe where the owner says, well, I want to go there because it's got a beautiful view. Or the cruise ship will say, well, this is the area we want to go because for whatever reason, there's, some scenic panorama or whatever. So the tender, as you can see, is moving back and forth using the multi-beam technology, mapping a very wide area. And again, at the same time, this mapping area is being shown in the bridge of the mothership in real time, helping the bridge crew and the captain to make their planning for navigation into the area. So this is the level of detail. Well, you probably all know more or less the level of detail you get with the WASP. Again, because of the number of beams, the accuracy of the sensors, the type of detail you're getting with WASP multi-beam is very high. So there are basically two ways to mount the wireless WASP system on the tenders, on the remote vessel. We offer two wireless WASP kits, complete packages. One is our W3 for fixed mount installation. If we look at the picture here, you can see the various types of parts. So the transducer, the DRX processor, the motion sensor, and the GPS satellite compass, Wi-Fi antenna, etc., built fixed into the tender. And usually this is done by the tender builders. So when we sell a package like this for a super yacht or a cruise ship, the packet goes to the tender builder, and they, actually we've sold quite a number of systems. So most of the tender builders around the world that build tenders for super yachts have already installed a WASP or know about WASP and how to install. We do have some installation instructions as well with examples of installations being done, which we can share. And that's, I think, the file that Rufus has shared with you guys got some examples of installations. And then recently, about a year and a half ago, we introduced our portable solution, which is W3P, and it's an all-in-one pole mount solution. And I would like to go into a little bit more detail of that solution, because it's basically almost like nothing is plug and play, but from my personal experience on some commissioning jobs that I've done recently, it was almost like working out of the box. So, which is a very good solution, for example, for a retrofit, because you don't need any modification to the tender. It can just be mounted on virtually any type of tender. I mean, you can see a rib type tender here. There is, fixed. For the super yachts, the type of tenders is incredible. The different types of tenders. But in any case, the W3P, the all-in-one pole mount solution, is where we have the whole package built into one single box with a pole or with a leg, and at the bottom the transducer. The only thing you have is a power cord, a 12 or 24 volts DC power going to the unit. That's all. Nothing else. No other cables required. No other connections required. And as you can see on top, we have a satellite compass. And if we show another installation picture here, it's the same same tender or the same rib here. And Andrew rightly pointed out that it's very, very important to because we cannot stress this enough, grounding. So absolutely very important to use grounding here on the pole as well. But that's basically for any WASP system, as you probably now are all quite aware of. So here's a very nice picture of another installation of the W3P, and also different type of mount. And we've got plenty of examples there as well. So what I would like to show you here very quickly is what's inside the pole. So just to give you a little bit of an idea, with what we do is we'll just pull apart the pole, the W3P, to give you an idea of what's inside. Right. So that was just quickly the pole being pulled apart, showing the various elements that are inside. So if I recap that, is we have on top of the pole we have the GNSS satellite compass. So that's the GNSS satellite compass, and what we do offer as well is we include a differential satellite-based correction service with the package. So that means that anywhere you go around the world, you will have improved differential accuracy with your GNSS. That's offered by a service called Atlas from the manufacturer of the satellite compass systems. So when you're out of an area that is covered by an SBUS service like WASSP or ECNOS, or there's some couple of other ones. If you're out of those areas, the Atlas service provides you with higher accuracy positioning. And that is, of course, when you're moving with your, especially with those vessels that are moving around the world, it's a very big benefit because it offers you sub-meter accuracy virtually anywhere around the world. So long-range Wi-Fi. So this is actually the Wi-Fi part, or the wireless part, that sends out the mapping information in real time to the mothership from the tender. So this is the long range from tender to mothership. Then there's a wireless router built in, and the wireless router basically communicates on the tender between your display, which in our cases we're using a tablet PC as a display, but it can also be a fixed computer. Most of the time, if you're using a portable system, you'll be using a tablet PC that you can, that you can mount on the steering console and take off as well. It comes with a nice bracket that it clicks in and clicks out. And so the wireless router is for that communication, the wireless communication of your mapping data. There's no wires in between the display and the actual unit. Then, of course, you've got your motion unit, your motion sensor for your heave, pitch, and roll corrections, the IMU, which is built in. And then, of course, the main brain, which is the WASSP DRX32 processor, built inside this box as well, going to our wideband fairing transducer, which is mounted at the bottom of the pole. So everything built in one single pole with just one cable for the power is all you need. And turn it on, and you only have to do your calibration, your usual calibrations, checking the wireless link, and then to the mothership, and then off you go, basically. So how does it look as a complete total package if we also include the mothership installation? Well, very simple. You've got the pole, you got your power input, 24 volts, you got your portable wireless mapping display, and of course you've got on the mothership the receiving part, where you have a wireless antenna, Wi-Fi antenna, same wireless access point, long-range wireless access point, going from, preferably the installation of the antenna should be in the highest possible location on the mothership itself. The thing is that as soon as you have blockage from some sort of object, which can be, an antenna or a mast part structure of the mast or something like that, when there's blockage, we immediately see, or you immediately will see, there is a reduction in range. So our rule of thumb is really like the best range you will get if you're line of sight, meaning, if you would look from the antenna on the mothership towards the system on the tender, if that's line of sight, then you can reach very, very long ranges for real-time for your real-time mapping information being transferred from the tender to the mothership. So from the mast, you go from the access point with a simple Cat5, Ethernet cable to the bridge. On the bridge, there is a PoE injector adapter, giving power to the access point and then going to the computer in the bridge. And the computer needs to be fed with NMEA information for position and heading from the mothership itself, because that will give you the indication of the mothership position, whereas the tender position information is coming through the Wi-Fi link. So you will have a computer on the bridge, any type of computer that's compatible with either CDX or time zero. And of course, a screen, you can have a dedicated screen. On the large yachts, you may have a video matrix where you can feed your video feed into the video matrix and then switch, on one of the big screens in the bridge console and have it displayed that way. Okay, so if we go back to the actual pole and its mounting, included with the pole is a mounting bracket that we see here. And the mounting bracket is where actually the pole sits in and is fixed in, and where you actually connect it or mount it to the transom or to the swim platform. Those are the mainly used locations where to mount the bracket for the pole. And so it can be vertically if you're mounting it to the transom, but it can also be horizontally if you have a swim platform on the back, which you've seen in the previous pictures. So it can be virtually mounted on any size of tender. Of course, you have to keep certain things in consideration. If you've got your prop, obviously you don't want the transducer to be in the prop wash. Same thing for the jet. So moving it to the side is usually the best solution. Again, we've got quite a lot of experience over time already with these type of installations. So anytime when something comes up and some questions, we can always give you examples of installations and also assist with suggestions and mounting solutions. Okay, so here is an example of how the pole is mounted on a horizontal plane, where you can see that it's quite easy to actually pull it up, because that's a possibility as well. It gives you the possibility in the bracket, the pole, to just pull it up. So for example, if you're not using it, you've been doing your mapping and you're going back with your tender to the mothership, then you simply just pull the pole up and tilt it. And as you can see here in the example, it can easily be done by one person. Tilt it and off you go. Same thing counts for the pulling it just up in order to change the height of your transducer. Again, it can easily be done by one person. And so this is yeah. Now that's the pole part. I briefly mentioned, we have the display where your mapping is being shown, and that can be in various, options. There's a possibility to have a wireless, a tough book or wireless tablet PC, which is, considered to be, if you have a portable system, considered to be the best solution because it's rugged. If you drop it on the floor, it doesn't break. It can be mounted at the steering console of the tender into a bracket. The bracket is included, and or the other option could be to fit it into a situation like a TCT screen, or even using an HDMI video input using a small little computer, depending on the type of installation and type of tender. But it's all possible. Okay, so here we have some real life examples that we got from some yachting customers. These are, basically what I mentioned before, where you have areas that no information is available whatsoever on, because it's part of the, the unmapped areas around the world where a lot of these large vessels are going. So this is an example of a chart showing no information whatsoever other than just the land contours. And here is how it shows when it's mapped. And again, this is because of the multi-beam technology, because of WASSP using 224 beams, the accuracy, the detail, everything is very, very nice. And also everything is done very quickly because you're mapping your very wide tracks. So with this here now, the mothership can easily go in knowing exactly what the various depths are where it's dangerous. You know, you can see the rock structures here, which are super dangerous for entering. But at the same time, they know they can easily, without any problems, move into this area. And we just have to imagine that this can be an area which is so beautiful, but no one or no large vessel would ever have dared to go in there simply because, you know, it was not mapped. So now they can actually do this. And I've got a couple of other examples here. This is another area, no information whatsoever. There's one depth contour here at the bottom, and then we've got some land, a little island, and some more. And then once it's mapped, here you can see the details showing up. And again, this makes it possible now for the mothership, for the large vessel to go in and, you know, navigate through these structures here and maybe anchor. You can use your backscatter information, so the bottom hardness, to anchor in areas where you can actually see where there's rock structure, where there is sand, so you can actually pick your mapping spot on the go. And there's another example here. So here we can see there's a little bit more information, you know, some depth contours, some lines. However, a lot of other information is not available. And this is actually mapping coming from one of the yacht customers that was in this area. And the very nice and interesting thing here is, as you can see, maybe they found wrecks. And they found wrecks, historical wrecks that were not on any navigational chart. So not on paper chart, not on the electronic charts, not even, you know, not on the ACTIS, not on any, non-official electronic chart. So they found wrecks. Now you can imagine if you have guests, charter guests on board, or, you know, guests on cruise ships. I mean, this will be heaven if you're into diving and snorkeling, because you can imagine how cool it would be to see those uncharted wrecks. And that's all being mapped because WASSP has been used to map the area. I think I went really quickly through my presentation. So because I'm closing off with this little video here, which shows real-time mapping. Can you not hear it? No. Okay, so I'll give a little bit of information because I understand that it's very hard to hear this. So
repeat it while you talk.
Yeah. So, this one?
Bottom left.
Yep.
You
Okay.
should be able to play and talk over.
Yeah. Okay, so sorry for a little glitch here, and I think the video already jumped to another. What I really wanted to show here is just to give you guys a little bit of an, some information on how it looks in real time. So the situation here would be what you would see on the mothership, on the mothership, showing the position of the mothership as well as the position of the tender in real time doing the mapping. And I hope because I've got a very low resolution going through here. This is actually a video on YouTube, so you could look it up, WASSP W3, and it will give you some more information also with commentary and things like that. But you see here a situation where the actual mothership has got a WASSP system on board as well. So they mounted a WASSP on the mothership as well as on the tender. And so both are mapping in real time. And this feature is available, the real-time mapping from two vessels at the same time is available in CDX. If you're using time zero, you will have one. So usually the remote vessel mapping showing on in real time. So instead of using CDX, you can also use time zero to show the mapping, real-time mapping from the tender, from the remote tender. In any way, the picture, the image you see here, you see the mapping showing up, you see the details, and that basically helps the mothership going into the uncharted area, now being available for. Let me see what I've got here. I think I go back to the previous one. Yeah. Okay, so if there's any questions, please let me know. It was just a quick presentation of what the system is, what it does, how you can use it. It's becoming more and more popular. Where the superyacht industry is growing exponentially. There's all the shipyards that are building large yachts and when we say large yachts, we generally the type of customer that would use and buy a WASSP system would be I would say 110 feet, 116 feet and up. And we've got customers with yachts close to 300 feet as well. So that's a large range, but in general, it is any vessel that is exploring and going to uncharted or poorly charted areas would be a potential customer for a wireless WASSP system to make their own electronic charts or navigational charts to go into to move into these areas. Now I know Andrew's going through some more details with about wireless WASSP tomorrow as the last presentation, and after this he's going through some technical training for hydrographic survey. Let me see if there's any questions. No, I don't see any real questions coming up. So what I can do maybe quickly, if I pull up the file that we shared with you guys on tender installations, so fixed installation on the tender. Yep.
This is a good question here from Josh.
Yeah.
Sure.
I don't see, where is it? Where's the question? Josh, concerning exclusively collision avoidance. No, I prefer a sonar, so it makes sense again. Okay, so so Josh, that's actually a very good point. So what Josh is saying concerning exclusively collision avoidance, obviously, if you are after collision avoidance while using, a super yacht or a cruise ship or any kind of large vessel moving into areas where, there can be collision avoidance, then the solution would be, while you're navigating, of course, you're not going to send out a tender vessel all the time. So in that case, what you would use is a sonar system that looks forward. In this case, for example, you could use a Furuno searchlight or Omni sonar, which are made specifically, of course, for fishing applications. But there are also professional forward-looking sonar systems. I'm not talking about leisure forward-looking sonar systems, because that's a different, different approach for a different market. If you're looking into forward-looking sonar systems for large vessels, you're looking into different type of systems, different categories. And yes, then you would use a forward-looking sonar for collision avoidance, collision to, for example, in the Arctic areas, a collision against, underwater icebergs. It could be collision against, rock structures, but even large mammals, just name it, or into reef structures and things like that. The discussion that comes up quite often, what we hear with super yacht customers is, why would I get a WASP if I already have my forward-looking sonar system? You know, my forward-looking sonar system can make a map of the area in front of me. So why would I use a WASP? Well, that's the thing is that this discussion comes up every now and then, not very often, because most people do understand that. For example, if you have a situation, and if I pull back one of the pictures that I had on my slides before with regards to you know, the areas where you see those vessels into exotic, uncharted areas. Let me just quickly click through. Where are they? Let me see. I think it's one of these. No. It's the one before this. So yeah, so if we're looking at a situation like this, if you have a forward-looking sonar, yes, it will tell you what's in front of you. But if you are in, for example, a lagoon with reef structure around you, there's no way that you're gonna move your 200 feet or 250 feet super yacht and turn it into the direction of where you want to go. I mean, it's just almost impossible. You cannot look behind a rock structure or you know, a mountainous area, as you can see here. How are you going to, you know, move your mothership into that direction and actually be able to see everything? You can only do that by moving actually into the area, but then of course you risk running against something. So in this case, you know, having the WASP on the tender of course can go very shallow. And if you send out the tender in front, it can map the whole area. And then once the you know, the area is shown on the bridge, you can safely navigate into the area. Also, the picture you see on the right bottom hand side is you see a reef structure. Your forward-looking sonar is not gonna look behind the reef structure. Your tender can. Your tender can go over the reef structure. It can map the whole reef structure. It can map what's behind it. And also, very important is the mapping coming from a forward-looking sonar. Just for the simple fact of, you know, the technology, but also the physics, is if you're looking forward straight down, you will never get any the accuracy that you will get from a professional multi-beam system like the WASP being mounted on your tender. So that's basically. I hope that answers your question, Josh, with regards to, you know, yes, if you're looking for collision avoidance during navigation. You know, you use a sonar. It can be an omni sonar or a forward-looking sonar. If you're looking into, you know, creating a detailed map for safe navigation into a certain area, then you know, the wireless WASP on a tender is a very good solution. And like I said, it's a very popular solution, and it's growing enormously. We have a lot of projects on the go at the moment. Interpretation of data. No.
Trying to understand what you see on a sonar.
Oh, yeah.
That's also a big benefit.
Yeah. Well, you can maybe go through those kind of details, but well, one other thing that I did not mention, which I think is also important to mention, is as I mentioned, you know, you've got your wireless link between the mothership and the tender. Now, we're using standard 2.4 gigahertz Wi-Fi, but we're using long-range access points, and so the sort of boosted kind of access point it is. The range that we have depends, that I did mention, that depends on the line of sight. If it's blocked by another antenna or a mast structure or something like that, then you'll see a reduction in the range. Line of sight situation, we have had situations where we could go up to 2 nautical mile range between the tender and the mothership, so that the real-time mapping information coming through. Now, what happens if you go completely out of range because maybe, like here you go behind the rock structure? Well, the tender will continue to do its mapping. The tender is just a WASP system doing its mapping, collecting data. As soon as you come back into your Wi-Fi range, into your line of sight with the mothership, when the connection is reestablished, the data that was being mapped on the tender was stored in its buffer or in its memory, and it's being sent out. We call it store and forward. So as soon as you come back into your Wi-Fi range, it starts to send out that mapped information. And once it's caught up, it will just continue to show your real-time mapping information.